All right, sorry I can't be with you today, but hopefully you're going to get something good out of this. So we're going to build on our lesson from last time. So instead of dealing with just dice and things like that, we can deal with any situation. So can we all agree for the fact that the Putnam Valley boys basketball team is better than Briarcliff? And I mean, Briarcliff's decent, so let's say the probability that Putnam Valley beats Briarcliff in any game is 3 out of 5. So if they play 4 games, what's the probability that they win 2 of them, that they win exactly 2 games? So you might remember this is kind of set up like the dice we did before. So we're going to say, well, of the 4 games, we can win any 2 of them. Okay, it doesn't say like they win the first 2 and they lose the first 2. So this is a combination problem. They can win, if they play 4 games, they can win 2 of them, any 2 of them. And then we take the probability of winning that game. So the probability of winning that game is 3/5. And we're going to win 2 of those games. And the probability that they would lose a game would be 2/5. And again, they would lose 2 of them. That would be exactly 2. So now if you go to your calculator and you want to type all that in, you can. Some of it's not too bad to do. 4C2 is 6. When you square 3/5, you square 3 and you square 5 and get 9 25ths. And the same thing here, we'll get 4 over 25. And when we multiply all that together, 6 times 9 times 4 works out to be 216. And then 25 times 25 is 625. So the probability that they'll win exactly 2 games is 216 out of 625. And don't worry, that probability seems a little low, but if your probability is 3 out of 5, you're probably going to win more than 2 games. We'll deal with that stuff in a little bit. So this is a situation that's called a Bernoulli experiment. It's named after this guy, Jacques Bernoulli. You might have heard of Bernoulli from chemistry, perhaps. So one of the things that he said was that if there's only 2 outcomes, like you win or you lose, you roll a 4 on a die or you don't roll a 4 on a die. There's only 2 outcomes. So if we let n be the number of trials and r is the number of successes, and p is the probability of a success and q is the probability of not succeeding, and please note then that q is equal to 1 minus p, because the probability of a success and a failure will always add up to 1. We can say that this is our little formula, if you will, to follow. So that will give us the probability of getting r successes in n trials. Yesterday we did it just for dice. Today we see it works for everything. And we're going to do some other fun stuff with it too. So let's say we have a biased coin. It's not fair. The probability that it lands out of heads is not 1/2. It's going to be 2 out of 3. So let's find the probability of obtaining 3 heads in 5 tosses. So first, our combination. In this case, the n is 5. We have 5 trials. R is 3. We get 3 successes. The probability of a success is 2/3. And the probability of a failure is 1/3. So we set up our combination then. We'll say it's 5C3. We multiply that by 2/3, and we want 3 of them. We multiply that by 1/3, and we want 2 of them. So take a moment, calculate that out. So 5C3 is 10. When you cube 2/3, 2 cubed is 8. 3 cubed is 27. When you square 1/3, you get 1/9. So we multiply this out. The probability of this occurring is 80 out of 243. Hope you got that one right. That's good stuff. All right, one last thing I want to throw at you, a little bit of vocabulary. So we got 5 multiple choice questions on a quiz. And there's 4 choices, like an A, B, C, or a D. And let's just say you randomly guess at each one. You don't even bother to read the question, just like bubbling on the Scantron. 2, 4, 3, whatever you want. What's the probability that you get at least 1 right? So remember that word at least means that number or more. That's what at least means. And kind of contrast that to maybe at most, where at most is that number or less. So if you go to an amusement park and you have to be at least 5 feet tall to go on a ride, it's 5 feet or taller. If you have at most $10 in your pocket, you've got $10 or less than $10. So that's the idea here. So let's see, if we guess at random, we want to get at least one right. There's 5 questions here. So our n value is going to be 5. 5 trials. But think about what you could get right. So the r value is going to be getting 1 right, or 2 right, or 3, or 4, or 5. Now don't go pulling that senior stuff on me and be like, oh, I'm not going to do this. Come on, stop. Let's think about this a little bit. That would be a lot of work to do 1, or 2, or 3, or 4, or 5. So let's think about it a little bit. Would it make sense that the probability of getting at least 1 right, so the probability of getting at least 1 right is 1 minus the probability of getting none right? Think for a moment. The probabilities always have to add up to 1. The probability of every single outcome has to equal 1. So if we can get 1 or 2 or 3 or 4 or 5 right, we're not getting 0 right. If we subtract that amount from 1, we get the same answer. It's a lot easier to do. I mean, yeah, do you want to do like your 5C1 and then your parentheses plus 5C2 and all that plus up to 5C5, all that? You want to do all that? You can do all that. I don't want to do all that. So what I'm going to do instead is I'm going to go 1 minus this 5C0. I want to find the probability of getting none of them right and subtract that from 1. So 5C0. So the probability that I get a question right. What's the probability you get a question right if you're guessing at random? Well, there's 4 choices, so the probability is going to be 1/4. And how many of those do you get right? You get none of them right. So if the probability of getting a question right is 1/4 if you guess at random, what's the probability that you don't get it right? You got it, 3/4. And we're going to get all those wrong. So this is what we want to figure out. So let's see what this comes out to be. 1 minus, if you go to your calculator, 5C0 is 1. 1/4 to the 0 power is 1. 3/4 to the 5th power is, let's see, 3 to the 5th is 243. 4 to the 5th power is 1,024. You're like, wow, how did he do that? Because I have it written on the board right next to me, and I'm just copying the answers down. I did it ahead of time. I'm not that good. Come on. So my answer is going to be 1 minus 243 out of 1024. If I go to my calculator and do that, or realize I'm just subtracting 243 from 1024, I get 781 over 1024. So the new thing for today probably, number 1 is this idea of at least or at most. Let's make sure we pay attention to that, using that vocabulary. And yeah, if it was like at least 4 right, you got to do like 4 or 5. But if you can simplify it, okay, I don't want to do all that. That's crazy. I'd rather do the 1 minus if it's appropriate to do so. So thanks for following along, paying attention to this. We have a little worksheet for you, and let's get some of these problems done.